Hi everyone, Nikita here. In this presentation, I am going to discuss the Stork Enamine reaction. This reaction was discovered by the Stork et al. It is used for alkylation or acylation purpose to carbonyl compounds. That means we can alkylate or acylate the carbonyl compounds using the enamines as intermediate. Enamines are composed of two words, that means ene plus amines. So carbonyl compounds can react with the 2-degree amines, that means secondary amine, then they will synthesize the enamines. Here we can see double bond and amine group, so it is known as enamine. These enamines are good intermediate and they can alkylate or acylate because the nitrogen has a lone pair which can shift toward the carbon, and double bonds carbon will shift towards this carbon. So here the carbon has a nucleophilic character. This carbon has a nucleophilic character, so it can attack on the carbon of the alkyl halide, and X can remove as a leaving group. So here we can alkylate this enamine, or we can say in similar fashion this nucleophilic carbon can attack on this carbonyl carbon and chloride will remove as a leaving group. So here the acylation has occurred on this nucleophilic carbon. In the by the hydrolysis we can generate the carbonyl compounds back in the product. Here we have taken one example where cyclohexanone are treated with the pyrrolidine, so they will form the enamines, and on the further alkylation, here the alkylation has occurred, this R group is ethyl, so here ethyl group is added. In the next step, last step, hydrolysis has been done, so here the produced enamine is converted back into the cyclohexanone. So by these methods we can alkylate the carbonyl compounds. Usually cyclic amines are preferred for the Stork enamine synthesis. Now coming to the mechanism part, first step is the formation of enamine. So how enamines can be formed? As I have told that there will be addition of the amines to carbonyl compound which contains a alpha hydrogen. So here the nucleophilic attack will take place. Nitrogen has a lone pair, so it can attack on the carbonyl carbon which has an electrophilic property. So the bond formation will take place between the carbonyl carbon and nitrogen of amine. After the nucleophilic attack, intramolecular proton transfer reaction will take place because nitrogen has 4 valency, so this proton will move towards this oxygen. So here we'll get this adduct. Now in presence of acidic catalysis or protonation, this proton will goes to the oxygen's lone pair. So here OH2 positive will form, so because oxygen cannot retain the positive charge for longer duration, so it will released by the formation of C double bond N. So here the water is removed and forming the C double bond N, where the nitrogen also contains the positive charge. Now to remove the positive charge of nitrogen, we can remove this proton and we'll just get back the nitrogen's lone pair. This proton can be removed by the base. So this iminium ion is converted into enamines by the removal of proton. So here enamines has been formed. Here we have taken 2 more examples to synthesize the enamine, where we have used the pyrrolidine and acetone. So simply here this will attack on this nitrogen's lone pair, will attack on this carbon, and here it will form the OH ion, and in the next step this OH ion will remove as a protonation, and so here this CH3 will give this proton. So we are getting CH2 double bond C which contains one CH3 is intact, and here is this amine group is attached, so we will get the enamines. Similar fashion, if we are using the cyclic ketone like cyclohexanone which is reacted with the 2-degree amine like pyrrolidine or piperidine, then it will also produce the enamines. So here we can see the structure where this structure is showing that this bond will move towards the oxygens, and after the removal of proton, just like the similar mechanism, we will get the enamine structure. Now, because nitrogen has a lone pair here, so it can goes to this carbon, and this carbon can have a negative charge. So this carbon has a nucleophilic property. So we can alkylate, acylate, or further can react in different manner to get the different products of the carbonyl compound. In the next step, these enamines as a nucleophilic carbon, so this carbon will attack on this alkyl halide's carbon and bromine will release. So we'll get the alkylated iminium ion. Because here the nitrogen has a positive charge, so it can be hydrolyzed easily, and when this in this step when the hydrolysis will take place, here this secondary amine will generate back, and here we'll get the carbonyl compound. So by the hydrolysis of alkylated enamines, we'll get back our alkylated carbonyl compound or acylated carbonyl compound, and secondary amines will be regenerated back. Now we can see its application. Enamines can use to synthesize a variety of product like different carbonyl compounds, or different alkylation can be done on the alpha position to the carbonyl compound. This enamines, if treated with the alkyl halide followed by the hydrolysis, it will provide the alkylated ketone, just as we have seen in previous slide. If we are treating it with the acyl chloride or any other alkanoyl chloride, then this nucleophilic carbon will attack on this carbonyl carbon, and here O negative will form, which will release the chlorine as a leaving group. So we'll get the COR group will be attached here. So we can say it is a acylated carbonyl compound because these two carbon are present at 1 and 3 position with respect to each other. So we got the 1,3 dicarbonyl compound by the acylation of enamines. Similar fashion, these enamines can further used for the Michael addition reaction with the conjugated carbonyl compound or methyl vinyl ketones. So these carbonyl carbons will attack on this carbon here, and it will goes like this. So 1,4 addition will takes place, in that will convert into enol. Further, by the ketoenol tautomerism, it will convert into the 1,5 dicarbonyl compound. So Stork enamine reaction can provide a wide variety of carbonyl compounds. Here we will see one or two conditions which we have to keep in mind for the Stork enamine reaction. If we are treating the enamines with simple alkyl halide like methyl iodide, then instead of carbon alkylation, it gives the N-alkylation product. That means the alkyl group will goes to the lone pair of nitrogen. So here we will get the quaternary ammonium salt, which can hydrolyze in the similar initial starting material cyclohexane and methyl pyrrolidone. So it does not give the Stork enamine reaction or alkylated carbonyl compound. Instead of simple alkyl halide, we need to take some reactive alkyl halide to get the alkylated carbonyl compounds. Like we can take the benzyl halide, allylic halide, or alpha halo containing carbonyl compound. So in presence of these type of alkyl halide, we get a good amount of alkylated carbonyl compounds. But if we are using a very simple alkyl halide, then instead of carbon alkylation, we'll get the quaternary ammonium salt that does not give the final product. Now coming to examples, here we have taken one substituted cyclohexanone. So here the asymmetric ketone is present. If asymmetric ketone is present, then in presence of secondary amines, it will form the enamines. But which proton will release to give the enamine? Then if the condition is less substituted and more substituted protons are present here, then which proton should release and provide the enamines? Then we'll always go for the less substituted enamines, because if it will form the more substituted double bond, then it will lose the planarity. So obviously it will give the kinetical control product. And further, this carbon has a nucleophilic character due to this lone pair transfer. So this will attack here and iodide will release. So here alkylation will occur. When we'll do the hydrolysis to generate the carbonyl compound back here, Here this ester group is also hydrolyzed and will produce the acid. So by this method we can synthesize the 2,6-disubstituted cyclohexanone. Similarly, we can see here the cyclohexanone is bounded with one aromatic ring at one side. So this side is hindered. If we are treating it piperidine, then it will form the enamine here. So here the double bond will come and here the nitrogen containing ring will come. Then this carbon will attack on this secondary alkyl halide and iodide will release. So here we'll get the CH, Me and isopropyl group. In the hydrolysis step we'll get back the carbonyl compound and secondary amine or piperidine will reproduced. So the Stork enamine reaction is useful to synthesize the alkylated carbonyl compound, acylated carbonyl compound. It can give the Michael addition reaction and so on. Thank you.